Today we're going to talk about graphing some linear equations, and in terms of those equations we're going to talk about graphing straight lines, because that's what a linear equation means. A standard form that those equations typically come in is this ax plus by is equal to c, and we've got some limitations on those kind of things. A and b are typically non-zero numbers. A is always greater than or equal to 0, so it's always positive. What that's saying? And A, B, and C must all be integers. C is going to be a constant, and A and B are always variable terms. So let's keep that in mind when we go to this next page and ask, are these equations linear? If they're linear, we have to be able to put them in this form right here. So once again, we try to make sure that the ax and the by term are on the same side of the equation, and I can do that here by taking and adding 7y to both sides. But since these aren't like terms, I have to just list it as 5x plus 7y equals 20. And this fits the bill on all this. A and b are non-zero. The a term is greater than or equal to 0, and everything is an integer. Now in this case, if I look at the problem, x and y aren't on the same side of the equation, so let's do that first. Add 3/8x to both sides. And that gives me 3/8x plus y is equal to 4. So in this case, a and b are non-zero terms. B in this case is 1, right? And a is greater than 0, that's fine, but a, b, and c are not integers, so I'd have to make those integers to be able to state if this is even possible. So to make these integers, I'm going to clear the fraction, multiply by 8. We get a 3x plus 8y is equal to 32. And now this fits the linear equation model, because now I have all integers. In this next term, get all the x's and the y's to one side, so I have a subtraction of 3 and a subtraction of xy. 3 and the 2 are like terms, so this goes to -1. These are not like terms, so I have 5x minus xy. So you'll notice my a term is greater than or equal to 0, but in my b term, I don't have a coefficient here. I have an x in front of the y. This is a deal killer, and because of this, it's not linear. Whereas the other two were. So let's talk about intercepts. The x-intercept is where a graph hits an x-axis, and the y-intercept is where the graph hits the y-axis. If I want to know where the graph hits the x-axis in this case, it's going to be right here. So 1, 2, 3, 4, 0 is my x-intercept. And here's my y-intercept, and this is 0, 3. That's my y-intercept. In this problem here, I notice that's where it hits the y-axis, and that's the point 0, 3. Once again, my y-intercept. And it looks like it hits the x-axis right around here, which appears to be -9, 0. And that's my x-intercept. Now one of the things you're going to notice in both of these is for any x-intercept, so anything that hits this line here, your y value is always going to be equal to 0. And for any y-intercept, anything that hits this line here, your x value is always going to be 0. That's important when we try to find these without actually having a graph. So we're going to actually graph these two functions by using only x and y intercepts. And like we said before, for my x-intercept, y is equal to 0. And for your y-intercept, x is equal to 0. So let's first set y equal to 0 to get my x-intercept. So I have 3x plus 4 times 0 equals 12. This gives me 3x equals 12. Divide both sides by 3. X equals 4. So 4, 0, I have an x-intercept. So now if I want my y-intercept, I'm going to set my x equal to 0. So I have 3 times 0 plus 4y is equal to 12. 4y then is equal to 12. Divide both sides by 4. And y is equal to 3. And then two points make a line, so I just connect the dots and continue on forever. And there's my graph. So let's do the same thing on this problem. Find the x-intercept. Set y equal to 0, so I have 5x minus 2 times 0 is equal to 10. This gives me 5x equals 10. Divide both sides by 5. X equals 2. There's that point. And then we'll find my y-intercept. We're setting x equal to 0, so I have 5 times 0 minus 2y equals 10. Negative 2y will equal 10. Divide both sides by negative 2 and get y is equal to negative 5. Once again, connect the dots. Oops, that's terrible, but you get the idea. And go forever. So now we're going to graph by making a table. And a table is basically consisting of choosing a few values for x and finding a couple values for y. So I'm going to pick 0, 1, and 2 are easy. I always pick 3 points. And I'm going to plug them into this equation and find out my y value. So if I plug 0 in, I have 5 minus 2 times 0, which is equal to 5. If I plug 1 in, 5 minus 2 times 1, which is equal to 3. 5 minus 2 times 2, which is equal to 1. So I have the following points: 0, 5, 1, 3, and 2, 1. And you'll notice these points seem to be in a linear fashion. I connect the dots, continue on out, and there's my graph. So now we're going to graph again by making a table, but this function is way more complicated because in my mind it's not simplified. What I usually like to do is isolate a variable, and if I can, whatever variable is isolated, I try to get rid of any coefficients in front of it. And we're going to try to simplify by getting y by itself. I'm going to clear this fraction. So multiply by 2, get 4x plus 8 equals 10 plus 3y. I'm going to get y by itself, so I'm going to subtract 10. It gives me 4x minus 2 is equal to 3y. And then what I'm going to do is I'm going to take and divide or multiply everything by a third. Or divide by 3, it really doesn't matter. So I can say divide by 3. I have to divide everything by 3, so now I have 4x minus 2 over 3 is equal to y. We're going to make a chart again. Whenever you have fractions in the problem, your answers aren't going to be as pretty. I'll pick the numbers 0, 1, and 2 again. So when I plug in a 0, I have 4 times 0 minus 2 over 3. And this ends up equaling, what is that? Negative 2/3. When I plug in a 1, I have 4 times 1 minus 2 over 3. So that's 4 minus 2, which is 2 over 3, or 2/3. When I plug in a 2, I have 4 times 2 minus 2 over 3. 8 minus 2 is 6, or 4 times 2 is 8, minus 2 is 6 over 3, which is 2. So now at 0, I have negative 2/3. Not super accurate, but I'll take a stab somewhere around here. At 1, I have 2/3 up. Again, not real accurate, but we'll estimate. And then at 2, I'm up at 2. So those pretty much appear to be in a straight line. I connect my dots. Keep going in both directions forever. There's your line. This is a unique problem here. It says y is equal to 6. There are no x's in the problem, but I still have to pick x's to make a table. So I'm going to go with 0, 1, and 2 again. And what this says is no matter what x I plug in, my y value is going to be 6. So if I plug in 0, I get 6. 1, I get 6. 2, I get 6. So here's 0, 6, 1, 6, 2, 6. Connect those, and I basically have a horizontal line. Here's kind of a word problem. It's got a little graphing in it. They give you an equation. It talks about telephone calls, etc., etc. We formulated these before. You're talking $4.95 a month plus 5 cents per minute, and that's your equation. We want to find the y-intercept of the graph of this equation. So if I want to find the y-intercept, set x equal to 0. And when I do that, in this case, m is functioning like my x, and c is functioning like my y. So if I want to know where that y-intercept is, I have c equals 0.05 times 0 plus 4.95, which gives me a c value of 4.95. So that's somewhere in here. So if I have part B, making a table, I'll plug in a m and get out a c. And let's go 20 and 40. Plugging in a 20, I get 0.05 times 20 plus 495. And that's going to get me about 595. When I plug in 40, 0.05 times 40 plus 495, it's 695. So if I graph these, 595 is right around here. 695, let's call it right around here. And in that case, I connect the dots. My graph is something like this. Lastly, if they talk 140 minutes, what's the monthly cost going to be? Well, that's basically saying our minute value, m, is 140. So my cost is 0.05 times 140 plus $4.95, and that'll give us a cost of $11.95.